Guys and girls, it's know it time! Hey, let's get crack-lacking! It's know it time! Know it time!
So I'm gonna wrap up the sheet from yesterday, and because some of you are still kind of lost on the sheet, I wanted you to take a look at this question we did yesterday. It says Lars borrowed $12,000 of 5% compounded monthly, and he's making regular payments of $350. Few keywords I want you to highlight. So in this question right now, highlight. So number one, he's making regular loan payments of $350. Okay? That's the first thing you should notice. Now, yesterday, what I taught you to do is you create a little table, and it turns very similar to this. This is called your amortization table. Okay? And we look through here, and it tells you exactly how long it takes him to pay it off. So, Leinard, how many months does it take this person to pay it off? Sorry? 38 months, right here. Because on the 38th month, he only needs to pay $25 and everything's paid off. But the problem with this is, let's write a few things down. Creating a table takes too much time. Okay. Too much time. Takes too much time. Because really I have to do 38 rows, and that takes way too long. So there has to be another method of doing that to figure out when he gets to that 38 months. So I asked you to highlight one word up here. Regular loan payments. Last chapter, you were taught a trick on how to find working with regular payments. How do we do it from last chapter? TVM solver. Grab your calculator out. Let's do this now with the TVM solver. Let's see who can figure out how to punch in your TVM solver. So what I'm going to do is I'm going to grab my TVM solver. We're going to do that question from yesterday. Yep, Lars borrowed $12,000. I want to know, we know it takes 38 months to get to zero. But now the question is, who can prove it using a TVM solver? See? The reason why I know I can use TVM solver, look, I'm making regular payments. So let's grab your calculator, turn on that TVM function. Again, every calculator is different. So my calculator has the finance TVM solver. The question is, who can figure out how to fill this TVM solver and get 38 months or 37? Now you're going to find a number. I'm going to pause it and let you figure out how to use a TVM solver. If you're lost, let's do this slowly. I'm going to go back to my TVM solver. It has 5% is my interest. Put in 5% right now, 5. Here's where it differs from your regular thing. In my last chapter, I put money into bank and my present value was $0. But now, I owe the bank money. So what should my present value be? Negative 12,000. Because you're losing money. So put in negative 12,000 right now. Yep, I know. Relax, breathe. Payment. PMT, look. So I read the question, and I'm saying I'm paying regular payments. See again? TVM solver only works best when you have regular payments. So put in $350 for payment. Because you owe somebody. That's why. Now my future value, 0. Because I want to know how long it takes me to get to 0. Nope. My PY is basically how much I'm paying, what's my value compounded. And that's monthly is put in 12 right now. So in this case, what I'm solving for is N. Go second or alpha, solve. And you should get, notice it's 37.07. Now some of you will ask, Mr. No, doesn't that round to 37? The answer is no. Because when you work with month, I have 0.07, so it takes me the next month to pay off that piece. Okay? So let's, if you make your future value, but then it's kind of reverse thinking. Yeah. I know it works, but you got to reverse thinking that. So let's write a few things. So if I use my TVM solver, n equals to somewhere on here 37.07. Using my TVM solver, n is 37.07. Now, the next question is this. If I look at my total interest paid, total interest. If I look at this, look at my total interest. Right now, my total interest is $975.66. That's from the charts. But now the question is, I'm going to let you guys play around with this. How do I use the n value to get this now? Using any math you like. I'm going to pause it. Let's see if you can figure out this next. So it's great that I can find the total interest, but I found the total interest using this whole table. Yeah, I'm going to make it a super no question. My question is, I know my n value. How do I use it to get the total interest? Using any math you like. Doesn't necessarily have to be TVM solver. Using logic. So I have my n value of roughly 37.0731. See, let's write this down right now. N, write anywhere you want because you're going to need to know this. This equals to total number of payments. That's what N stands for, total number of payments. I made 37.07 payments, but in reality, there's no such thing as 0.07. That's why they rounded to 38 months, and that's the reason why. But the issue here is, so let's do this right now. Let's use my whole value. 37.03.07 31859 31859 That's how many payments I made. Now the question is, if I go back to my original question, how much did I make per payment? 350. So why don't we just multiply this by 350? That's it. Okay. Wait, let's just do this. Because N is how many payments you made. 350 is how much you paid. So I said it's very simple. Some of you use TVM solvers, some of you, I don't know what you're doing. So let's do this slowly. You go 337.0. Again, notice I'm using all my numbers. If you don't use all your numbers, you will make a mistake. Times 350. Okay? So this is how much I contributed if I did this right. But in reality, my loan was only 12,000. So guess what I'm going to do? Minus 12,000. And when I do that, I get roughly, and it's about 6 pennies off due to my rounding before. So guys, that was it. So this is a quick way of finding a rough estimate of your total interest, which is 975.6. Again, it's around 4 pennies off, which, I don't really mind. But it's a quick way, because TVM solver, like I said, is a rough, quick estimation. So instead of doing 38 lines, what we can do is we can use the TVM solver and do it in 2 lines. That's the power of the TVM solver. We're going to do this now. Next one. Now, no, we did that. The question is this. Trina borrowed $500 from her friend at 3% compounded monthly. She's planning to pay back $50 every month till her debt is paid off. It says create a table, but now I'm going to ask you to do this using the TVM solver. So we're going to go do this again. Solve using TVM. Okay. So I'm going to ask you a few quick questions. A, how many months does she need? How many months? The exact, well, you know, you have to round to the next month. Because you have to. You always have to. There's no exception to that. B, because there's no such thing as 10.1 months. And you can say, Mr. 10.1 is 10. The answer is no. Because that 0.1 month will take you the next month to pay it off. That's the reason why you get around to the higher one. Regardless if it's 10.1 or anything. Now, what's our total interest? Total interest. Going to be, take a minute, work with the person beside you. We're going to solve this using TVM. See, it's going to take me too long to create a table, but now, sorry? Is it 10 months or 11? You got to be careful with this one. But when you actually solve it on your total interest, you're going to use the true value. Okay, not the 11th value. So again, I'm going to do this slowly. Okay, so I borrowed TVM solver. And I don't know what it is. My interest. Put in 3%. Calculate the sheet over there. I'm paying every month, which is 12. But now I borrowed 500. Make sure it's negative 500 because you owe that much. My future value will be 0 because that's I want to know how long it takes me to pay it off. I go up here and I go alpha. Oops, something's wrong. Hang on. Oh, my payment. I'm paying too much. I'm paying $50. There we go. Alpha. It says, notice it says 10.13977, but in reality, that's going to be 11th month. Some people say, so 10.1 rounds down, but in reality, when you work with payments, you can't say 0.1 will just pay it all in that 1 month. You got to go to the next one. So it's going to be 11 months to pay that much off. B, what is your total interest without using the table? To find the total interest, you take this whole number. If you round, I will deduct marks. You have to use the whole value. So I go 10.139, 139, what was it? 77683, 77683 times 50. See, notice I'm using my whole value right there. And let's do this right now. So 10.139, 77683 times 50 minus your original that you borrowed, which means you paid only $6.99 in interest in that 11 months. $6.99, which is not bad. And that's what actual banks rates do. No, it has to be the exact penny. Now, we're going to do this exact same question again with B. If Trina is planning to pay off her entire debt at the end of the year in one single payment, highlight this key word for me, please. One single payment. If I give you one single payment, can you use a TVM solver anymore? No. Not the simple. You're going to use a compound formula. Take a minute. I want to use the compound formula right now. Write down the formula for me. So A equals to P, open bracket, 1 plus R over N to the power of NT. See the difference between regular payments versus one payment at the end of the year. Take a minute, plug it in, and tell me what the interest is. Notice I'm only looking at the interest. And then you can compare which interest is bigger or smaller. So is it better to pay monthly, or is it better to pay off in one big lump sum and say get over with? Sorry? 15? I don't know, we're going to do this slowly right now. My p-value was 500. 1 plus R, what was my rate before? 3%? Compounded monthly. Okay, slowly, give me 1 second. 12. Now, if I pay it at the end of 1 year, N, it's just 1. Which one? T? N? No, N it represents compounded what? Here it says compounded monthly. Uh-huh. Just think of this. I invest $500 at 3% compounded monthly. How much money would I get back in 1 year? Think of that question. Okay? So what we're going to do, yep, that's what I'm going to pay at the end of the year. So now, punch in your calculator. Let's figure out. Again, this is going to be careful about this one. Divided by 12. Oh, 0.03 divided by 12. My 1's not working. Oh, my 1's not working. There we go. Plus 1 to the power of 12 times 500. But we're not done yet. That's my total value. What's my interest? Because you got to be careful what I ask. Because some of you lost 1 mark on this because you didn't write down the interest, right, Harjaz? Now minus 500. So which is 15.21. So if you wait for the 1 year, you're paying almost double the interest. Or more than double the interest. Okay? That's why people pay their mortgage monthly. If they wait and say, I'm going to pay it off in 25 years in one shot, you're going to owe them an arm and leg. And that's why your parents paid them off monthly. Now this one, which is better, paying off regular installments or one lump sum? I just showed you this one. So regular installments is a lot cheaper. You save a lot of money by doing regular installments. Okay? Less interest. That is what we're going to do next. So I have a worksheet comparing one single payment versus regular payments. So I'm going to pause it right now. I'll give you your. So if I look at this question, I noticed a few key things I want to highlight for you. This person is making one lump payment at the end of 5 years. Say, I'm going to get it over with. Wait until 5 years later, done. I did that before, and I think that was the biggest mistake in my life. I owe a student loan $24,000, and I'm going to say, you know what, I don't have money now. Well, call me back in 5 years. And then, yeah, I lost a lot of money because I didn't know about this. That was before I became a math teacher. Sorry? Yeah, except I didn't think about this sort of thing. I was like, I'm too lazy to deal with you every month. Because every month they would call you and say, you owe us money. I'm like, just call me back in 5 years and we'll talk. But apparently, I said, call me back when I have money. Because I don't have money. And then that was a big mistake. So, yeah. So right off the bat, I know that you can use the TVM solver, but I don't want to because it's going to screw you up if you do. So you go A equals to P, and this looks like another regular investment question. To power NT. Now, if you're lost, we'll just do it slowly. Lavraj, what's your P? 1,000 is correct. Jason, what is your R value? Good. Over. Now read, what's your N value? 1. To the power of 5. Make sure you have a 5 here. Because NT, my N is 1, my T is 5 years. Punch it in. And what you're looking for is really, I'm looking for interest. I'm not looking for how much I made in total. I'm looking for interest. $338.23. Whew, that's a lot of money. Okay. But now, let's change it up a bit. What if Stacey is planning to pay back $210 per year until the debt is paid off? How much interest will she have paid? If she does this, I'm going to pay you $210 per year until I clear all my debt. I'm going to pause it again and let. How much interest will she have paid? Oh, I'm going to show you exact same questions before. So I'm paying. That's the best way to do it. Gerdaman. Here we go. $210 per year. And notice I'm paying a regular, so this is right up at it keys TVM. Quickest way. Grab your TVM solver out and let's do this question. finance, TVM Solva. So again, I'm going to modify my TVMs based on this. My interest. Interest is 6. Present value. I borrowed $1,000. So I put 1,000. I'm planning to pay $210 back every year. My PYCY. Mirage, what do you have for PYCY? 1 is correct. Oh no. Because PY means how many payments per year. I didn't say it takes me 5 years. So now we're going to figure out how many years it takes her to pay this off. So I go solve. It's going to take her 6 years to pay this off. 5.77 to 12.64 for what? Oh, interest, I don't know yet. So again, notice I'm going to use the whole entire number. 5.7747. 5.7747. Say I'm using the whole entire number. 299. One more 9. Times 210. So let's do minus my original loan. So 5.77472999 times 210 minus my original loan, which is 1,000, and gives you $212. So let's do the minus. Where did I punch in? Oh, I screwed up on one of these numbers.
It's 2 fours. Yeah, it's 2 4.
Oh, I forgot 1 4. That's the reason why. But it's roughly 212. What was it? 6 4. So if I look at this, compare the difference in payments. Is it better pay back in one lump sum or in installments? Installments. Because I just showed you. Next thing. How would, let's say this, you have more money per month now, and you decide to pay from $210 to, you're going to pay $250 this time per month or per year. How would the interest change? If I say I'm going to put in an extra $40 per month, and let's see how much money you save. So let's do this one last question. It does, but it also changes your interest. You pay less, but the question is how much less do you pay? So let's do this slowly. Now I'm going to change my payment to $250. Okay, so it goes alpha solve. Now it's 4.70983. So let's write this down. 4.70983. How many threes there? Make sure I don't screw up this time. 1, 2, 3, 2 times 200. Now notice I'm changing my payment. This is $250 now. Take a minute. Why don't we punch this in our calculator? 4.709833332 times 250 minus 1,000. $177.46. $177.46. Look at the difference in payment. See? I save, how much did you save, Narit, you said? You saved about $35 by paying just an extra $40 a year in the long run. That's the power of TVM Solver. And this is called an amortization table, which is what your parents are currently doing right now. If they have a mortgage, this is sort of the thing they calculate every single day. Okay? They calculate, if I put in a bit more money this month, I save a bit more in the long run. So, and this is sort of thing everyone who owns properties, who has a mortgage, I'm still calculating what is my perfect payment right now. Right now, my mortgage, like how much you can actually afford before you go bankrupt. If you pay too much, you have no food. So if you pay, but the beauty about it, if you pay a lot right now, when you retire, you save a lot in the end because you pay less interest. Right now, my payment for my mortgage is over $2,000 a month. A month, over two. So my paycheck, you think, Mr. No, you have so much money? It goes right back to the bank. The bank takes it all. I don't keep a single dime. And all of that goes to my interest.
You don't live alone, do you? You don't live alone, do you?
I do? I do.
You're building a new house by yourself.
House party.
House party, please. So now,
Girls ain't doing